Good morning, and thank you for joining us for today's webinar in our continuing series on SSH. So far, we've been talking a lot about a number of aspects of SSH as far as its configuration and the security that it offers and access control. And why do we really care to be talking about SSH? Well, there are the security issues, and some of us may be seeking to truly improve the security. That may be our goal and our mission, to improve the security. And this has come into conversation a lot driven by some sponsored reports that were done by the Ponemon Institute and Forrester Group. And those reports presented some pretty scary statistics about SSH. They had crazy numbers. 50% of all enterprises don't have a plan to secure SSH and haven't done anything. 75% of all organizations have suffered some kind of a breach due to lost keys. Very, very scary numbers. They were tightly tailored reports. And more recently, the NIST document 7966 guidance on automatic authentication. All three of these documents are really good reads. They're all really good information on SSH. And if you have an SSH project, or if you believe that your enterprise needs to do more, do better to secure SSH, it is possible that you could use those documents as a tool to help people understand the problems you may be facing. Now, they're all very narrowly focused, and we'll talk a little bit more about that. But there is the security issue. More often than not, what we find is security is not necessarily the driving factor. It's not the checkbox that people must check off. A lot of times, our security projects are really driven by compliance. There's a set of rules out there that say that for our particular industry, we must do this and we must do that. The nice thing is that some of these regulatory regimes are encouraging our enterprises to implement some real security. They can give the security administrators, the systems administrators that see that their systems need to be secured better and want to do a better job. It can give them the ammunition to get the will, the corporate funding behind the project to meet compliance. And compliance tends to have several different areas that are spelled out that need to be met. And SSH and our system security for it falls into three different buckets. There is the access control. Our regulatory regimes talk a lot about the access control. There is the privilege management, controlling what people can do once they get there. Our regulatory regimes recognize the inherent power of administrative credentials. Very, very important bridge the gap in understanding access control. It's not everybody, it's especially the most important people, the most important accounts that we have to focus on. And audit and logging. Because no matter how good your access control is, if there's a breach and you are not logging that access, if you're not auditing those records, you are completely blind, even with the best security in place. So we care because, yes, we do want to secure our enterprises, but also because compliance is driving security into industries. Now, in previous webinars, we've talked about SSH, and in the first one, we talked about it in general terms about how using an out-of-the-box configuration, SSH offers a number of controls that can allow us to define the security of the SSH service itself, the access control that who is allowed or disallowed from using the service, and functionality. Some of the things within SSH, particularly you can think of tunneling. We can turn tunneling on or off. And that last example is a good example for the limited control that the local, the native SSH configuration gives to us. They're really global settings. If we're going to enable key-based authentication, then by and large, SSH enables key-based authentication for any account that has a key present on the server. Password authentication, we turn it on. We can use the allowed and denied users or groups, but by and large, it's any account that has a password on the system. So the local controls are, to a degree, limited controls because it's really all or none choices. We also talked about how with SSH, in a local configuration model, it's decentralized. It can be very hard to manage. I could probably do a fine job managing 10 servers, and with an effort, I could probably do a good job managing 100 servers. It would take quite an effort, but if I had 500 or 1,000, 5,000, or even 50,000 servers, as some of our customers have, the task is absolutely overwhelming. And with 50,000 servers, that customer has a small army of people available. It's a large corporation. And even with an army, it can be very difficult to manage so many systems unless you have some way of bringing it all together. So the security concerns that we talked about with local configs is that, yes, they're decentralized, which means that we would have to manage it server by server, an administrator going in and touching these different places. But the real security concern with local files controlling a critical service is that, well, local files can be manipulated by local administrators with root privilege. That root account, the all-powerful root on all of our Unix and Linux systems, can touch everything, can touch anything, can do anything. And that means that if we are reliant on local files, then we've extended complete trust and the integrity of our access control model to anybody who is able to exercise that level of privilege. This is the insider threat at its essence, that root administrator or that root account can do anything. And when you have this situation, we all like to believe, we all want to believe, we want to think that we've hired the best, most trustworthy people that we've seen time and time again. And I hate to use it as an example, but the Snowden incident is an excellent example of trust being extended to somebody who usurps the authority they have or finds ways to usurp the authority granted to others to do things like siphon off data or manipulate the configurations of systems. Another example from the news recently is at Home Depot, they'd hired an administrator who had gone in and leveraging his high level of access to systems, did some very, very bad things to their systems. And, you know, we want to be able to trust our insiders. And that's fine. But trust is one thing. Verifying that that trust is well placed is the effort that we have to make, because we have to extend our level of trust, but we should trust and verify. So who is who? To SSH, who is not a person. It's an account. The SSH service does not know that a person is behind the keyboard or that it is the person that the account belongs to behind the keyboard. Now, we have a lot of different types of accounts, too. We have the administrator accounts, the people accounts. those people that we trust and that we've hired to do the job, to maintain our environment, to make sure that our business can go. Whatever that means, whatever application, scripts, data we have, we need people to man those machines to make it all go. But who is not just people? To SSH, who is any account? It can be a service or functional or application account. This is what the NIST 7966 guidance is all about. Applications reaching out from one server to another. Now, it's not a person standing there. They cannot type in a token code. They cannot type in a password. We need some form of automatic authentication to allow these applications to function, to reach from one place to another. It could be transactions in the financial institutions. It could be transactional data that's going back and forth, very small bits of data, rapidly sent, high volumes of these transactions that are being transmitted from one system to another. It could be something as simple as a backup service, a script that runs on one box and pulls data over to another, or pulls data out of a database to provide some kind of application, operation, or function. And then, of course, there are system accounts. Now, primarily, root is the system account that we think of, but there's many system accounts. If we have an Oracle database running, there's an Oracle account. If we have a MySQL database running, we may have created a MySQL account. Apache may run as Apache. Now, typically, people don't log in over SSH as these accounts, but as I mentioned, with global configs, it doesn't mean they can't. There are ways that they can be used to do that. They don't necessarily need to have a password, and they shouldn't. That would keep them from logging in. We could take their shell away in a local configuration. We can make it no login. And a lot of times, our administrators may go and look at these system accounts, take a quick look through Etsy password, and see who has no login. Okay, my local service accounts, none of them are allowed to log in. They don't have a shell. But what if an administrator dropped a password into Etsy Shadow? Okay, they still can't get a shell. But if you have tunneling enabled, they could use that account with that password to log in without launching a command from their SSH client. They could build a tunnel. Is that something that you want to happen? Do you want people attaching to your server and building a tunnel as Apache? It simply should not be possible, let alone be done. And if we have our configuration locally, it takes many files, a number of these files, to pull everything together. So we have to watch all of these different places. And in my experience, the shadow file is the least watched of all. And yet, here's a simple example of how somebody could make a minor modification to it and slip right in unnoticed, potentially. So to SSH, who is who? Who is accounts? Our administrators, or our functional accounts, or system accounts? And who do we have to defend against? Well, there's our insiders, our regular users, our people. It could be a system administrator who potentially could have root access. It could be a database administrator or an application or service administrator. Systems administrators typically are not the guy running the database, so we have a whole different set of people that have expertise in that particular application. If it's a web server or some other application, we're probably going to have a different bucket of people that have the skills and need to do that work. Or it could be our developers or testers. Any number of different classes of users who need to get in and be able to do different jobs. Well, all of them, if they can get in over SSH, they're on the system. Well, we need to be able to defend against any one of them. As an example, I mentioned a large customer, 50,000 servers. That's a lot of servers to manage. How about 30,000 users spread across those systems? How would you do that? How would you do that with your current tools? Is it something that can be achieved without having to have an army to do it? So we have our regular users. those people that come in that have a job to do. We'll call those maybe developers, application administrators, database administrators. Then we have our real system admins, the guys that come in, and they need some level of root privilege. They need to be able to control, modify the operating system, the services, the underlying components. They need deep, deep access. My gosh, we all hope that we can really trust these guys. And you know what? Most of the time we can. But again, with our insiders, even the people that we trust, compliance is driving us toward a model of trust but verify. It's okay to trust people, but make sure that they're doing the right thing. Now, we don't typically think of insiders as these application or functional accounts. We don't think of insiders as these service accounts, but they kind of are. They are accounts that are inside of our enterprise. Even if they're only inside our system and they don't represent a person, they are an account that we own that is local to us. And although we do have to defend against insiders, the attackers are the ones who are really dangerous and working really hard to get into our networks. And here's the thing. Although an attacker may come from the outside, they may work some minor breach, spear phishing attack, where they get into somebody's laptop, someplace on the edge of your network, on the outside, through one of your users, through some completely unprivileged system. They are going to get that toehold, and they are going to take that toehold and try to rob it of account information and make a foothold. And then they're going to take that foothold and they're going to pivot from one system to another inside of your network. And the first thing that they're going to be looking for is vulnerable services and administrator credentials. The attacker, they're not going to look like John the attacker coming across your network. They're not going to have an account that announces them. They're going to look to you just like your most trusted administrator, because those are the credentials that they're going to steal. Or they are going to appear like one of your applications starting to behave a little odd. They're not going to come in and announce themselves. They're going to farm the credentials from your insiders, and they're going to leverage those credentials to work their way through your network, through your infrastructure, and their goal is to get to your data. Most attackers are not there to vandalize your systems, to mess up the configurations. That's an insider threat. The attackers are there to quietly work their way in and through and around until they get something that they can convert to a monetary value, and that's going to be your data. So the threat we have to defend against, if we consider that we must build a defense against those privileged credentials, that insider credential, not necessarily the user, but you have to defend against their credentials being misused. It may not be misused by the person you hired. Those credentials may be misused by people that have attacked your network and stolen them through stolen credentials or stolen keys. The stolen keys, again going back to the automatic authentication described in NIST 7966, these functional applications, automatic authentication cannot be somebody standing at a keyboard, so often the authentication of choice for automatic authentication is SSH keys. And the suggestion is that you need to tightly manage, broadly manage all of the keys and know where they are. Well, box server control does it differently. We manage the access. We manage and enforce at the target the access control. We define it tightly and narrowly. And our detection is not detecting things that are misplaced. Detection through enforcement. As soon as something bad is attempted, we stop it and we notify on it. So what must we do? Compliance is dictating that we must report, and these reports are about who has access to what and when. Our regulatory regimes want to know that we are monitoring our systems, to know what accounts are present, how they can get there, sometimes when they can get there, how they can get there. Our compliance regimes have put some privilege management in there. They want to know that you know who has the ability to do, especially the administrative things. So reporting is a very big part of it. It drives awareness. These rules are all about you knowing your network, your systems, your accounts. And if you have to know them, the assumption is that means that you have to manage them well. So scale accounts, something that hasn't been used in 90 days, that's a line item in a report. And it's a line item in a report because an account that hasn't been used for 90 days is one that you're supposed to be considering whether it needs to exist at all or not, or whether it's just sitting around waiting for some attacker to find those credentials and start using them. Because every account is a vector into our system. Fewer accounts, fewer vectors. The more vectors, the more we have to monitor. Monitoring is hard. It can be a lot of data. And monitoring is the other big thing that our compliance regimes drive us towards. Not only do they want us to periodically be able to report on information, they want to know that we're watching real time, that we know what's going on. Can you tell if an administrator has SSH'd into a server 100 times in a day from 15 different systems? Is that normal behavior? Maybe. I don't know. I don't know your enterprise or how it works. But it certainly could be odd behavior. And depending on where in your network they're coming from, it could be very odd behavior. Are they accessing through the VPN at the same time that they're accessing from the IPv LAN? Is the connection to the VPN coming from some other country? Kind of hard to be in two places at once. It's happened. Somebody was once caught doing something a little different than threatening our data. He hired outside contractors to do his work, and he was sitting in the office and he was VPN'd in from China. So compliance is telling us that we must do these certain things. And that's good to know, and that's good for us to be able to do. Now, what else can we do? Along with the monitoring the accounts, monitoring our access control rules, monitoring our access, is managing privilege. Not every account needs to be capable of doing everything. Database administrators typically do not need to be root on our servers. They certainly like to be, many of them, but rarely do they need to be. Now, there's a couple different ways to do this. There are tools, local tools like sudo, where you can manage on a system-by-system basis who's allowed to do what. Again, decentralized solutions like that can be very difficult to manage, even through a central management tool like Puppet or Chef or whatever. You're going to have to handwrite some of these things and figure out what groups to associate them with, and then you're going to have to put them into the distribution. And then you're going to have, well, some privilege management, maybe, but it's going to be disconnected from whatever you're doing for account management, maybe OpenVAS or some other tool. It's going to be disconnected from the access control rules that you have to write for them to actually be able to get in. So privilege is a key aspect to the overall solution. Securing our servers, securing our SSH, sure, it is about the access control rules for SSH, but as discussed in a previous webinar, it's also really about account management. And this is that last step. Manage who? The account that can access, and how. Account management, access control, privilege management, and enforcement. And especially important is when somebody oversteps their authority, to be able to notify and report on the misuse of an account seeking to gain greater privilege than was granted to it. So local versus centralized. A local solution requires us to manage 3 different things, 3 different ways, and typically in 3 different places. Each one of these is associated with the other, so we have to have information from one to adequately configure and enforce at the other. They're all interrelated, and I would argue that they should be intertwined. Box server control is a centralized solution. Box server control brings together cross-platform account management running across all the various Unix and Linux flavors. It allows you to create those accounts and distribute them, either as an account or as a class. So we can have an account or a group of accounts that are distributed and bound to a host or bound to a group of hosts. It allows us to define access parameters for the SSH based on who, from where, when, how they're allowed to access, and how they must authenticate or are allowed to authenticate. It allows you to define the privilege that will be granted to the account on the host once they arrive. So maybe we have one group of Oracle servers in production, one group of Oracle servers in development. I've got a class of users that are Oracle administrators, a class of users that are Oracle developers. Very simple for me to deploy that. Whether that's one developer and one administrator on 2 servers, or 20 of each across 100 servers. Very easy to bring it all together and manage users across hosts and be able to define their privileges and to provide the monitoring and the reporting that our compliance regimes require of us. And this is the box server control solution. It brings all of these together for our Unix estate, providing a solution that not only provides the regulatory compliance that many industries require, but also provides real, tangible security in your deployment. We welcome you to reach out to us if you'd like to learn more about box server control. We're certainly happy to talk to you more about how our solution would solve your problems. And you can join us again next month. We are going to talk about NIST 7966. We're going to talk about what its recommendations are, and we're going to map how box server control mitigates the issues reflected in that guidance. Thank you very much for your time and attention. Have a wonderful day, a wonderful week, wonderful weekend, and we look forward to hearing from you again soon. Thank you.